Today we'll be talking about Lenses SQL processors and how to use them to create dead letter queues. What are dead letter queues, when to use them, and what to do after you've created them is all topics we'll be discussing today. We do have our development and engineering team on as well, those who aren't already on PTO. So feel free to raise your hand, ask questions, and post questions in the chat. We'll be sure to have some Q&A time at the end as well for anything we left hanging. So this is our weekly session. If you're new, we do a Thursday 30-minute session on a technical deep dive, tips and tricks about working with Apache Kafka and how Lenses makes your life easier. So today is obviously covering SQL processors and dead letter queues. It's the last session of the year, and then we'll be kicking off the fresh year talking about streaming with data mesh architectures for event-driven applications. We'll follow that up with a hot button topic, and that's feeding LLMs, AI, machine learning, generative AI applications with streaming data. So making sure all of your nice generative applications that everybody's working on are up to date with real-time information and what we can do to enable that. And who are we? We are Lenses. We provide a developer experience for Apache Kafka with all the bells and whistles that you would need when working with Apache Kafka, saving you from operating at the command line. You get a nice fancy user interface, full governance structure applied. And we're also the largest developer of open source connectors too, which we now provide enterprise support on as well. So definitely let us know if you're interested in developer tooling around Apache Kafka or some open source connectors. And with that, we'll dig right into it. Today, again, we'll be covering stream processing with SQL and our take on that, being Lenses SQL processors, the ins and outs of that feature of our product, the mindset and problems we are looking to address when developing that feature, and why our take on it is unique. Then we'll be using SQL processors to create dead letter queues, talk about situations where you might want to do that, and what to do, how to process information after you've created your dead letter queue and separated that bad data out. And so quickly on Lenses SQL processors, Kafka is fantastic because it's super flexible, highly configurable, but that does tend to lead situations where either you've got bad messages into Kafka, or you just need to do some transformations to be able to sync that data to an external data source. So this could be normalizing an event log for syncing into a relational data store, but then also the fancy things like aggregating to get state out of an event log, filtering and enriching and joining data together as well. So typically requires working with Java code and Kafka Streams applications, which also requires developer experience, somebody highly technical. And that's why we've developed Lenses SQL processors. So this was actually the first SQL engine developed for stream processing. And if you see on the left here, you have an example of a Kafka Streams application designed just to split a topic into two separate topics. We have our orders topic, and we're separating that into approved and denied orders. Again, typically requiring working with Java code, the Kafka Streams library, developing all of that out and then deploying it, managing the connection to Kafka, lots of overhead, which equals significant time to value, and issues with, if there's a problem, higher mean time to resolution as well, because you have to get into the code, takes experience to understand the expected behavior and what needs to be changed. All of that compared to the option on the right, where you have that exact same behavior with a few lines of Lenses SQL. So just a quick example of saving you some time and money working with Kafka Streams. Hari, I see that you have a question. Would you like to come online and ask?
What is the exact difference between the KSQL and the Lenses SQL?
So we'll get into that in a second. One is that we developed our SQL processors before KSQL DB was ever a thing. And then one significant differences would be the actual architecture layout. So great question. I'm about to get into it. And then coding your Kafka Streams app would be the first step on a long journey. You still need to package that application, deploy it, manage that connection to Kafka, set it up with monitoring and alerting so you can be sure everything is online and your production app is good to go, as well as governance, and then again, troubleshooting, lots of issues there that we're looking to address. And today we'll show you how easy it is with Lenses compared to Kafka Streams or other options where no coding experience required. As long as you're familiar with SQL, it should be very intuitive. And this is just one set of features included in our full developer experience, significantly reducing the time to value and mean time to resolution if there's ever an issue. And there's the question asked about how does this differ between KSQL DB? And I think one of the most significant ways that we differ is one, it's different syntax. We use our Lenses SQL syntax for SQL Studio and asking ad hoc questions, as well as Kafka streams. We also have different architecture layout. So instead of deploying each transformation job into a KSQL DB cluster with shared resources, our Lenses SQL processors deploy on your Kubernetes cluster within a namespace as its own pod. You can easily assign exactly how many resources that transformation gets, and you can manage the full lifecycle of that application as well. Makes it really easy to scale up and down runners to flexibly handle increased or decreased load. You know exactly how many resources that transformation is getting, and don't have to worry about noisy neighbor problems of one transformation on a KSQL DB cluster taking up all of those resources. So issues that we've heard from our customers and partners that we look to address with our Lenses SQL processor. Again, this is one feature that's included in our, excuse me, full developer experience platform too. So you get all the synergies of all the extra features and governance structures that we provide with the Lenses DevX platform. Yeah, Harry.
Yeah, if I need to develop a custom plugins or a custom things, can I develop in the Lenses? Same, how about it?
Yeah, absolutely. So you can configure Lenses with your own user-defined functions as well, which makes it really easy for you to share those functions with your team. So if there's a common operation you're looking to perform that isn't included by default, very easy to add that too.
Thank you.
Yeah, great questions. And with that quick overview on SQL processors, you know what we're working with today. We'll show you how to make dead letter queues and cover what those are. So what is a dead letter queue? Why do we need to know this? Why is it important? And keeping in mind that Kafka works as your event log for applications that are speaking to each other or data integration pipelines. Sometimes we get bad messages in our event log, in our message flow, and this can lead to issues downstream. And that could cause problems like a consumer failure. That consumer is not able to process a message, it'll just fail by default. Can also result in maybe you have a team producing data that tends to be inaccurate. So this can take the form as data fields missing, an email or name missing from an actual Kafka message, but also negative or zero values where you wouldn't expect that to. So all scenarios that we'd want to handle upstream and address within Kafka before syncing to an external source and addressing any sort of consumer connectivity problems. And that's why we use dead letter queues. And why would we, what scenarios are we protecting against with a dead letter queue? There's two that high level scenarios that come to my mind when I'm talking about dead letter queues, which would be technical error handling. So here we're talking about maybe a message that was produced to say a JSON topic that is actually corrupted so that the data is not readable, it's unable to deserialize, and this will result in a consumer failure. A consumer will be attempting to read from that topic, unable to process a message, and then fail at that offset. And then the other scenario would be business error handling. So this is just inaccurate data. You can still consume the message, but the data within it is inaccurate, which leads to downstream data quality and consistency issues. So both scenarios, we'd like to deploy a dead letter queue to filter out those problem messages and process later. And speaking of processing later, what do you do after creating a dead letter queue? So you've separated these problem messages out. You've got them stored in a separate topic. Now what? Our consumers are still running and active. We still have bad data coming into our DL queue. The first thing you might want to do is, and none of these are mutually exclusive, you can do any and all of these, and depending on what the problem is, there's different options and appropriate steps to take to addressing the issue. So one of the things you can do in Lenses is easily alert on data being inserted into a dead letter queue. So you've set up a dead letter queue as your filter. You want to know as soon as a message is stored and produced to that dead letter queue for you to handle those problem messages. You can also resend a message. So if I receive an alert, my dead letter queue has data in it now. That could be assigned to the producing team that, hey, maybe that data was corrupted, but I can easily resend that message and hopefully it goes through and it flows all the way through my data flow and out of Kafka. You can also easily sync that dead letter queue to an object store for reporting to an external team. So that's when you tap another team on the shoulder and say, hey, we're seeing a significant amount of data flowing into our dead letter queue. Here's all the problem messages, fix the issue. Always nice when you can put it off on somebody else. Another option too is utilize a dedicated consumer. So if there's a consistent problem, but you're aware of the pattern, you can sync all of those into a dead letter queue and create a custom consumer to actually consume those messages from the DLQ into your downstream store. And with that, we can do a quick demo of creating dead letter queues in Lenses today. So I'm here in my Lenses environment. I'm logged in as an administrator, so I can see everything in our topology. This would be every single data flow, every app that's producing data into my Kafka cluster and syncing externally. Today, we'll be working with our New York City yellow taxi trip data topic. Click to that in the topology, see where that data is coming from and what's being done with it downstream, and a quick overview of topic metrics and information here. I'll jump into the data set, take a closer look. From here, it's really easy to expand an individual message and understand what's happening with this message. But I can also view the topic data as a table, which is my preferred way of getting familiar with this Kafka topic. You also notice that we have our Kafka metadata here as well. So if I'm new to my company, I can easily understand who owns this topic, who to contact before consuming, and what channels to subscribe to for any schema changes. So we have our taxi trip data here. Everything looks good at a first glance, but I'll jump to SQL Studio to start asking ad hoc questions about my topic data. And here's where we start to get familiar with the data and understand if there's any issues. The autocomplete is a fantastic feature, makes my job easier. And I'm going to be looking for messages where we had a New York taxi trip, but the passengers was actually 0 or less than 1, which obviously is an issue if I'm running a taxi business and there's no passengers in my taxi. SQL Studio is going to act as a Kafka consumer, and it's going to read from my topic and start presenting messages that meet this filter syntax. And immediately, I start seeing some messages rolling in that indeed have 0 passenger count. So this would be representative of the business error, where we have messages being produced, but it's either inaccurate, letting us know that there's an issue with the data, but not the message itself. So to address this and segment that data out, stop it from affecting our downstream data stores, I'm going to create a dead letter queue. With that, I'll jump to our applications, and we'll develop a SQL processor to create our dead letter queue. Again, our SQL processor is SQL Kafka streaming, and we'll be deploying this as a Kubernetes pod on our cluster. I'll just give it a quick name. This name will be used as the Kafka consumer group. I have some suggestions for configuration, but I'll go ahead and manually set my config here. With these config settings, I am actually setting a read and write failure policy and setting that as DLQ. So although I'm looking to address a business data problem, I can easily set these configurations here to address a technical issue as well. So what I'm saying is that if this SQL processor has issues reading or writing data, if there's a corrupted message and I'm unable to deserialize it, or there's a different issue and I'm able to deserialize it, but unable to write to the downstream topic, it's actually going to write that into a dead letter queue for me. So I'm addressing the technical error problem as well as the business error issue with this single SQL processor. And then I'll just give that technical topic name. And that will be the topic that the SQL processor dumps any problem messages to if there's a technical error. And with that, I'll develop the rest of my SQL processor. Here I'm saying I'm going to insert into a new topic. And first we want to make a clean topic for any messages that don't meet our delineation of bad messages. So any message that doesn't have 0 passenger count, we wanted to sync those into our clean topic for consumption by consumers, because this is the actual data that we do want syncing into. And they'll say where passenger count is greater than 0, because we know that is appropriate, is actually the topic that we'll be looking to read from. Air handling in here is fantastic because I don't have to deploy my transformation and wait for it to fail. It'll let me know that my syntax is wrong off the bat. And this will be where I'm writing my problem messages, essentially any event that represents a taxi trip that has 0 or less than that passengers. Again, autocomplete to the rescue. And I'll add that second filter. I have been told this isn't the most efficient way to do it, so we do have a more efficient way to structure this exact same SQL processor, but just for clarity and brevity, this is fine for now. So we have the first part, a configuration that says if I'm unable to read or write a message, a technical error, we're going to sync that into our technical DLQ. Now, if we have a problem with our business data, we're going to sync that into our business DLQ for later reporting, syncing to object store, or just alerting an upstream team. Now that I have the SQL processor developed, saving me from learning Kafka streams and developing Java code, simple and easy SQL, I'm going to go down to my Kubernetes information and configuration here. So I'm connected to my cluster. I can select a namespace, and then I can select number of runners as well. So it'll be number of pods that I'm deploying for parallelization. And there's advanced settings as well, where you can specify specific amount of memory and CPU. With that, I'll go ahead and create my processor and give it a start. This is my favorite part. Once you start it up, it takes a couple seconds and you get to see the messages in and out and bytes as well jump, if you did everything right. Any questions while we're waiting for it to come online? Oh, yeah. And there's our jump. Fantastic. You can see each of the individual pods coming online. And then it's really easy to jump to that in our topology. So I can see that I have my producing application, producing yellow taxi trip data to my upstream topic. I can see that I am filtering that out into 2 separate topics, one for those messages that have 0 passengers and the rest that are actually clean and representing an actual taxi trip. So now I can reroute consumers to consume from my clean topic, addressing that business quality problem. And then I have my topic here where I am writing messages with 0 passengers. I can jump to that business DLQ here and verify that indeed I'm seeing passenger count as 0 for each of these messages. Again, I can view an individual message really easily or view it all as a table, which makes it much easier. And yep, all of these messages have 0. So I went ahead and deployed my DLQ. The data quality problem is temporarily addressed, and now I need to process all of the messages here. Again, those options could be alerting on data being produced here. So this could be easily done within our metrics panel. Outside of the alert component, it's easy to set up alerting for this topic. If it receives more than 0, then I would want to know about that. It could be even 100. You can specify depending on your requirements. This is going to send my team an alert, letting us know that, hey, there's been some data that's inserted in this DLQ and needs to be processed. It's also really easy to sync this topic and all of its data into an object store for reporting as well. So I can easily back up this topic to my S3 bucket. And Lenses will actually deploy an S3 sync connector and stream all of this data into my S3 object store. So as soon as there's a message produced in my DLQ, it's going to be written to my S3 bucket. My team will be notified of that, and they'll know exactly what the problem message is. Fantastic. And that's really all there is to it. This has been creating DLQs with SQL processors.